Alright, hello again. So we are back for our next video in the Python Programming for Kids series. So now we're going to continue a little bit with our game programming. Last time we got Visual Studio Code set up, so I'm going to be using that going forward because it'll make a lot of our programming easier overall. And so if you haven't gotten that set up, I would suggest you go take a look at the previous video to see how we got that set up. So I'm going to go ahead and open up Visual Studio Code with the shortcut I put on our desktop. And so let's recap where we left off with our game from before. So if I go and find our game where we left off. So I think Pygame 7, drawing the score and lives on screen. So let's run the game just to see what is going on. So if we do go to the Run menu and click Start Debugging, and then select Python file, that should bring up our game here, which we have on the window. Let me restart that. We noticed this last time, there is this exception that occurs when you call sys.exit. This isn't something to be concerned with now. We'll get into explaining why that's sort of occurring later, but it's fine, nothing you need to worry about. We'll get to it later. So let me run our game again, and if I move the window over here to sort of the top right of the screen, and I will put Visual Studio Code over to the left here, because I'm going to walk through the code while we look at the game here. So if you look at our game, we have our player as this white square in the middle. We have our collectibles, which are red squares that we try to collect, and we can move around with the arrow keys on our keyboard to try and collect those collectibles. And when we collect one, you saw our score increase here by 1. We see we can't move outside of the boundaries of the screen. And this little blue fellow here is our current enemy. And if we happen to get hit by our enemy, as we just saw there, the number of lives we have would get reduced by 1. And so now to recap a little bit of what's going on in the code here. So if you were to look at our code here, we start off by initializing Pygame. Then we create our game screen, how big it is in pixels here. That defines how big our window is going to be. You can easily adjust that. We load our initial font and set the size, so that's how we are going to use that for drawing like the lives and score text there. Then we basically just initialize a bunch of data, a bunch of variables that control the different things about our player, the collectible, the enemy, and so on. These are variables we're going to update as the game goes on. And then here we enter what is known as our main game loop here, which has a lot of code. We're up to over 200 lines in this program thus far. And so once we enter this game loop is going to basically continue to run until our user chooses to quit. And then otherwise it's going to continue to update our game. So the first thing we do in our game loop is handle like these events, which get sent to our game program, our window here. These are things like keyboard presses, clicking the X button in the top right screen of our window for quitting, and so on. Mouse clicks can go through here as well. And one of the specific things we're doing here is we're having the player move based on keyboard input. So anytime I press like the up arrow key, our player will move up, left, down, right, and so on. So we're just handling all the keyboard input there. Next we do, after handling input, we basically do all of the sort of updating of the state of the different entities or things in our game. So we're doing things like making sure the player is kept on screen. We're automatically moving the enemy and keeping the enemy on screen. We're checking if the player ends up intersecting or colliding with our collectibles here, and then collecting those and increasing the score if appropriate. We're also checking if the enemy touches the player. And so that's all of our updating of like the state of our game. The next thing we do is we basically do all of our drawing for the game. So while we're updating these things in variables in the computer's memory, we need to actually do something to sort of transfer that memory to the actual screen window that we have. And that's what the drawing sort of phase of our game loop does. We clear the background first. That's important to basically prevent what was drawn the last time through this loop, the last sort of frame of animation from persisting. And then we basically just draw the different components of our game. The player, the collectible, the enemy, and then the lives and score. And once we're done, we're saying, hey, display that in the window. So that is the current state of our game. Now, even for me, as a relatively experienced programmer, as we start to look at this code, it's only a little over 200 lines. But the amount of different things going on in our game loop is starting to get pretty complex, even for me to, understand and keep in my mind at once. And therefore, it makes me very hesitant. I don't feel very confident in my own abilities to just start adding new features to the game with the way all this code currently is. It's hard for me to keep it in my mind. So what I want to do is find ways to sort of take some of the things that are currently in my game code and put them into more reusable chunks that I can easily read and understand at once without having to wade through all of this code. And so that's going to be critical for us starting to add more screens or game states to our game. For example, at a minimum, we're probably going to want to add like a title screen, for example. That's going to be separate and have like completely different behavior from all of this sort of gameplay code that involves the player being kept on screen and moving the enemy and so forth. Like that stuff wouldn't like appear on the title screen. We wouldn't have the keyboard input be the same there. And so we're looking for ways to sort of capture those things in what are known as abstractions that we can more easily understand and therefore think about and reason about our program and hopefully have it be more correct. So a lot of terms I just threw out there, we'll revisit them again and again in the future because they're very important. So how are we going to start to do this? Well, to start, what I'm going to do is create basically a new Pygame program and delete all the code that we don't care so much about in terms of getting this idea of having multiple like states or screens working. So at a minimum, I want to start off with, let's have a title screen and have that separate from like the main gameplay state. So that's what we'll do here. I'm going to save the existing file here as something different. I'm going to call it Pygame 8. Stubbed out title screen and gameplay state.py. So that's what we're going to aim to do here. So now I want to basically go through and remove all of the code to start that I don't really care about for the purposes of what we're doing today. So I'll start off by saying I don't really care too much about all of this initial data about the player, or collectible, or enemies, so I'm going to delete those. We're still going to want to keep all of this initialization stuff here at the top. And then probably want to keep the quitting logic here, but we won't really want to have the player moving based on keyboard input. I might want to keep the clock updating here, so I'm going to leave that in for now. We don't really care about the player or the enemy. We don't care about the collectible, so I'm going to delete all of that code. We're probably going to want to keep the screen cleared, and then I don't care about the rest of the drawing code for the most part. We just want to sort of have the frame still updated in the window. So now if you look at our code thus far, it's much simpler than it was. It can almost fit on, the screen. Not quite, because I have my font size increased, but you can see it almost fits entirely on screen at once. Very simple compared to what we were doing. So next I'm just going to run this to make sure there isn't anything that's crashing in a crazy manner. So our window still seems to be working. It's black. We can close it. We get this exception, which we'll deal with at a later date. Okay, so what to do next? So I want to have a title screen, and I want to have sort of a main gameplay state, and I want to sort of keep the code isolated so it's not all intertangled and intermixed, and therefore get more confusing to understand. So how do we do that? Well, one of the first ways we can do that in typical programming languages use what is known as a function, sometimes known as like a subroutine or a procedure, but we'll just use the term function for now. And a function, you can think of it as a little bit like a miniature program. So if you were to have, if you think about your regular program, right? Oops. So if you think about your little program here, you typically would have, so your little inputs and outputs here. So, for example, for inputs, for like a game program, you could have like keyboard input, mouse input, and so on. Now, if you are looking and thinking about sort of the outputs of your program, then you could have outputs, which would be like the graphics displayed on screen, audio, so sound effects, music. So that's sort of what's going on with typically any program. You have some inputs, the program does some stuff, then you have some outputs that the program produces. So a function or a procedure is very similar. You could think of it as sort of a miniature program within your program. But then what we do is we give it a name that makes it a little easier to understand. So hopefully that's a little bit clear now. It might not be super clear, but we'll revisit it continually as we go on. So how do we create a function in Python? So I'm going to start by going up to part of our code here right after my import statements, but before the rest of the code for my game. And then what I'm going to do is have a function that basically is going to handle updating and drawing our title screen. So how we create a function in Python, we start with this keyword called def, D-E-F, which is short for definition. We're basically saying, hey, we're going to define a function, and we'll give it a name, update and draw title screen. And then after we have our name for our function, we have an open parentheses and then a closing parentheses. Within those parentheses, we can take what are known as parameters. You see that in some functions we call elsewhere, like down here. We have screen width in pixels, screen height in pixels, and then we have like font file name and the font height here. So we can have our function take parameters, which are basically like the input data. We're not going to have any input data for this function right now, so I'm going to leave it empty between these parentheses, but we might add something later. So next, after we have the parentheses, we need a colon on the first line of our function signature, which basically defines what it, sort of how it's called. And then we can press enter to go to our next line, and you'll see in Visual Studio Code it automatically indented 4 spaces here. You'll need to indent the same way if you're using another editor or if Visual Studio Code doesn't do it for some reason. This indentation is important because it's how we identify all of the code in our function, very similar to the way things were handled with while loops and for loops. So if in our function I were to type a bunch of statements, this is just all not valid code right now. But anything that's indented at least 4 spaces underneath here is part of what is known as the function's body. It's the code that would get executed when we call that function. If I were to unindent this line here, then this line, this last line here, is not part of my function's body. And so therefore, anytime I call this function, this wouldn't be executed, only these 3 statements would. Alright, so to start, I'm just going to very quickly stub out a function with a print statement, which will give us an idea of what our get an idea that this function is being called. I'm just going to type in title screen. So this is some dummy logic here. And then what I want to have happen in my game is basically every time we go to update and draw our game, we're going to sort of update and draw it within our game loop. So I'm going to start by calling our function here, and I do that by specifying the function name and then having parentheses to call it. So if I go to try and run this program now, if you look at sort of the bottom terminal window in Visual Studio Code, you'll see it's continuously printing out title screen. And so that shows that our function here is getting called. Now, to give you a little clearer picture of how the flow of this code executes, I'm going to put what is known as a breakpoint here. That's this little red dot. By clicking sort of in the space to the left of a line number in my program. And I'm going to step through the code and show you the flow of execution here, because that's very important to understand what's going on. I'm not going to fully cover using the debugger in Visual Studio Code right now, because it's a huge separate topic. You can try to follow along at one if you want at home, but for the most part, just try and watch where the code is executing when I run this program. So if I start to run and debug it here, you'll see what Visual Studio Code did is it put this little arrow right next to the line that's currently executing. That's where I put a breakpoint. And you'll see here this little sort of toolbar here which lets me do various things. Continue running my program, stop running my program, I can restart it. Then there's these step over, step in, and step out operations. We are just going to do the step over for now, which lets us sort of step over each line one at a time. So if I do that, you'll see it sort of gradually executing the functions. You'll see when I did import Pygame, it actually printed out some little help text message which shows that, hey, Pygame is like successfully installed. So now if I continue with that, stepping over, you'll see if I step over here with our function, you see it didn't actually go into that print statement. It jumped over that. So when we are stepping over here and we see this def function, the Python debugger recognizes this whole thing as a single entity or thing. It's a function, so it sort of steps over this as like a single statement identified by the def keyword, the define statement here. So we haven't actually executed this function yet by virtue of you not seeing like the print title screen text down here. So if I continue to step over, you'll gradually see not too much happening for a while. We get into our game loop here, and then if we keep stepping over with this button, we'll eventually get to this update and draw title screen function. One thing to notice here, our window has actually popped up at this point. So rather than step over, what I'm going to do now is step into, which lets us sort of step into a function call that we have. And what we'll see here is if I do that, the flow of execution here is going to jump from the computer executing the code at line 50 all the way back up here to line 6 in our function. So here is where it is printing out, going to print out the text for our title screen. Now if I try to step into this, it's not really going to do anything because I couldn't step into the third-party print function that comes with Python. I don't have the ability to do that. But what happened is you see it executes this function and then it sort of returns back to where we were left down here. But the key thing to notice is that it actually printed out the title screen text you can see down here in the bottom left of the terminal. So now I could continue stepping over that again, and then if we go to step through our game loop one more time, then we get back to this function again, we step into it, we call print title screen, you see that gets printed again, then we're back here at line 50, and then the code would sort of resume as it is going on. And so that's sort of the flow of execution, how things jump around in functions, and then that's why we get title screen printed a lot here. Okay. So that's our first stubbed out function here, update and draw title screen. Next, I want to have another function that at least starts to add one more game state to our program. So we have we're going to have another function which we create with the def keyword. I'm going to say update and draw the main gameplay state. So that's the name of our function here. And then I'm just going to stub this out for now, adding in some print statements. I'm going to have it print out main gameplay state. So just to show you that this works, I'm going to go back down here and change update and draw title screen to update and draw main gameplay state. And then if I run our program now, I'll delete this breakpoint because we don't need it. You'll see now it's printing out main gameplay state in the terminal window. So we at least know that these two functions are working independently. But then the question becomes, okay, how can we have our program sometimes draw the title screen, but other times draw the sort of main gameplay state code? So this is where we'll have to use some conditional logic. But what I'm going to start off by saying is, and I'm going to go up here to the very top to define some constants related to this. So what I'll say is I'm going to create a constant to hold the name of the title screen state, and we'll just say that this is known as title screen, and then main gameplay state. We'll create another string constant to indicate that. And then what we'll also do is have a variable that indicates what the current gameplay state is, or the current game state, which is going to start off with on the title screen here. So all I've done here is define some constants as indicated by my styling of this uppercase. And these are basically just sort of arbitrary values that indicate what we're using to say, hey, this is the title screen versus the main gameplay state, or something else we might do later. We could have done a lot of other different things here. We could have assigned the title screen state to like the number 0 and the main gameplay state to 1. I didn't choose to do that because it's a little easier, more self-documenting, easier to read if we have, values that sort of match what our intent are. So that's why I chose strings here. You don't have to do that, and there are different reasons why you may or may not choose one or the other that are beyond what we can talk about today. And then after those constants, I'm going to have a variable that indicates the current game state, and we're going to just have that be the title screen state to start off. That's where we want our game to start with. So how can we change this? Well, to start, let's go down here to near the bottom of our for loop, where our game loop, where we are drawing and updating our current gameplay state. And so really what we want to do here is just have some basic conditional logic and say, like, if the current game state is equal to the title screen state, then we're going to update and draw the title screen. You can see me taking advantage of like the autocomplete or IntelliSense stuff there to sort of get the functions I need and then easily select them with the up and down arrow keys and then press enter. So I don't have to necessarily type so much, which is a little quicker. And then else if the current game state equals the main gameplay state, and I press enter to automatically select that, then we're going to update and draw the main gameplay state instead. So let's run our program and make sure that's still working. Okay, so if I do that, it seems to still basically be working. We're printing out the title screen stuff, and that's what's going on. But we don't have a way to switch between the two states. So how can we do that? Well, for now, I'm going to do something very simple, which we'll change later. We're going to do something like change the game state if the user presses a key. So how do we do this? Well, I don't recall off the top of my head, so I'm going to go to my web browser and go to pygame.org and look at the documentation. I think there is this key module, and see what's going on here. So the Pygame event queue gets Pygame key down and key up events when the keyboard buttons are pressed and released. So what I think that means here, and I'll hopefully show here, then I can do something like if pygame.keyDown, and you could go reference our previous code to see what's going on here, is equal to event.type. Then what we're going to do is change the game state. And so how can we do that? Well, I'm just going to do something pretty easy now, where like any sort of key press will switch which particular game state we're currently on. And so what that means is that if the current game state is equal to the title screen state, we want to change the current game state to be the main gameplay state. Otherwise, else, we'll just have the current gameplay state changed to the title screen state. So I think that will be an easy way to sort of just get that sort of stubbed out and working for now. So let's try it, see if it works. So if I run my Python file, you can see it's currently drawing the title screen based on the text output here. If I press a key, you see it switched to the main gameplay state, text being printed out. I press another key, we go back to the title screen, and then I could try pressing a key again, and hey, we're back to the main gameplay state. So that appears to be working. We can check this out by if I put a breakpoint here for the key down event, and if I press a key, then you'll see the debugger starts going here. The current gameplay state is main gameplay state, so we'll go into the else block here and we'll change the current game state to equal the title screen. So after I step over that, you'll see the current game state is equal to title screen. So we can continue running our program, and then if we were to get down here to the drawing code, you can see it checking the current game state against these constants I defined, and since we're currently have the value of title screen in there, which equals that, then we can go to update and draw title screen and step in there, and you'll see that's where it calls the print statement that we have. So that's all I think we're going to cover for today. There's a lot in there, getting a little bit of an introduction to the debugger in Visual Studio Code and starting to think about how we can manage our game program just with functions that do different things and then switch between which one's getting called. Obviously, we don't have the actual gameplay or title screen implemented. We just have sort of a black screen now plus this terminal output. But I wanted to get you acquainted with the basic ideas here before going further. So next time we'll look at, okay, how can we actually implement these functions to draw and update the title screen and main gameplay state so that they're doing something a little more realistic, closer to our actual game. So that will be it for this video, and we'll see you next time.